Large language models, or LLMs like GPT, which stands for Generative Pre-trained Transformer, have truly revolutionized the way we interact with technology. These AI systems have the capability to understand and generate human-like text, making them incredibly valuable across various applications, from writing assistants to customer service. Their ability to learn from vast data sets allows them to perform complex linguistic tasks, often with a degree of sophistication that can mimic human thought processes. However, despite their impressive capabilities, these models are not without their limitations. They operate primarily on the data they were trained on, which can rapidly become outdated. This means that while they can generate text that feels real, their knowledge is often static, fixed at the point when they last learned from their data. The implications of this static knowledge are vast, influencing everything from the nuance of language generation to the factual accuracy of the content produced. As we integrate these models more deeply into our digital interactions, their limitations become more apparent, pushing researchers and developers to seek enhancements that can make these AI systems more dynamic and responsive to current events. The primary challenge facing current language models is their inability to access and utilize real-time, updated information. When users interact with these AI systems, they often seek answers that reflect the latest knowledge and current events. However, standard LLMs can only draw on their pre-existing databases, which may not include the most recent information or contextual changes. This limitation can lead to outputs that are outdated or irrelevant, diminishing the user's experience and trust in the AI's capabilities. For instance, if a user asks about the latest advancements in renewable energy, the model might provide data that was accurate months or even years ago, but not today. This gap between user expectations and AI capabilities highlights the need for models that can access and integrate up-to-date information seamlessly. Furthermore, the static nature of these models' knowledge bases means they cannot learn or adapt in real time. A user correcting a factual error or updating information cannot influence the model's future responses. This one-way interaction restricts the AI's ability to evolve and stay relevant, which is critical in our fast-paced, ever-changing world. Retrieval-Augmented Generation, or RAG, addresses these limitations by combining the best of both worlds: the generative capabilities of LLMs and the dynamic retrieval of information. Imagine a librarian who not only knows a vast amount of information, but can also pull the latest books from the shelves as new publications arrive. This is what RAG does on a digital scale. The process starts with a user query. The RAG system first consults an up-to-date database or library to find the most relevant and recent information. This step ensures that the content it generates is based on the latest data. Then, using this freshly retrieved information, the RAG model generates a response that not only answers the user's question, but does so with current insights. This approach allows RAG-enhanced models to maintain all the linguistic prowess of traditional LLMs, while also providing responses that are timely and contextually appropriate. The integration of real-time data retrieval into the generation process ensures that the AI remains as informed as the latest database entry, dramatically enhancing its utility and relevance. One of the most significant benefits of retrieval-augmented generation is its ability to increase the accuracy and trustworthiness of AI-generated content. By ensuring that responses are based on the most current information, RAG reduces the risk of disseminating outdated or incorrect data. This reliability is crucial in fields where staying up to date is essential, such as healthcare, finance, and news reporting. Moreover, RAG fosters a deeper trust between users and AI systems. When users receive accurate, timely information consistently, their confidence in the AI's capabilities grows. This trust is fundamental to the broader acceptance and integration of AI technologies in everyday life. It reassures users that they are interacting with a system that is not only smart, but also informed and up-to-date. Additionally, the adaptability of RAG models makes them more robust against the rapid changes in data and context that characterize our digital age. This flexibility allows them to be applied in various dynamic environments, ensuring that they remain useful and relevant regardless of how quickly external conditions change. The applications of retrieval-augmented generation are vast and varied. In the realm of virtual assistants, RAG can power more sophisticated and helpful AI assistants. These enhanced assistants can provide users with the latest information on everything from weather updates to traffic conditions, making them indispensable tools in daily life. In content creation, RAG enables the production of up-to-date, relevant articles and reports. For instance, journalists can leverage RAG-enhanced tools to write pieces that incorporate the very latest research and data, ensuring that readers receive the most current insights. This capability is particularly valuable in fast-paced sectors like technology and finance, where conditions can change overnight. Moreover, in educational settings, RAG can transform how students and educators access and use information. By integrating RAG systems, educational platforms can provide learners with the most current materials, adapting to the latest scientific discoveries or historical developments, thereby enriching the learning experience and keeping curriculum up to date. The potential future developments of retrieval-augmented generation are as exciting as they are transformative. As technology advances, we can anticipate RAG systems with even greater capabilities, such as more nuanced understanding of context and user intent. This will further enhance their precision and usefulness across various applications. Additionally, as more sectors recognize the benefits of RAG, its integration into new domains will likely increase. This could lead to innovations in how we manage information, make decisions, and interact with AI on a daily basis. The adaptability and up-to-date knowledge provided by RAG could fundamentally alter industries like legal research, medical diagnostics, and personalized learning. In conclusion, the continuous improvement and expansion of RAG capabilities hold tremendous potential for making AI not only smarter, but also more relevant and responsive. As we look to the future, the role of RAG in shaping the evolution of AI is undeniable, promising a landscape where AI's potential is fully realized in its ability to stay informed and insightful.